Hello, I'm joined by Chae Clark of 26 Technologies, where Chae is the lead machine learning researcher. 26 works with the national security community on cybersecurity and data science projects. Today, we're going to talk about a project we're doing together for DARPA, which is the R&D arm of the US DoD. Specifically, Chae is going to share insights about how we're working together to enable model tuning and training on encrypted data sets in order to build better cybersecurity detection models. Chae, thanks for joining me today.
Thanks for having me, Ronen. I'm excited to be here.
So as you know, we're going to go over the 5 questions that you see on the screen. Basically, give everyone an overview of the project we're working on, the privacy challenges, solution, and then get your vision for the future. So why don't we just dive in? Can you share a little bit about the problem that DARPA is trying to solve and what we're doing?
Yes, and really the problem DARPA is trying to solve is the sort of marrying of two technologies. So on the one hand, you have sort of the defense of enterprise networks from malicious actors. So enterprises are generally pretty good at preventing an attack or an exploit once that attack has happened on their network. Uh, but this doesn't sort of then confer that same protection to other enterprises or other networks. On the other hand, you have sort of the development of machine learning techniques that have made pretty decent strides in sort of the area of network defense or sort of mitigation of attacks. But the success of these models is sort of really tied to the quality of the data used. So wouldn't it be great if we could sort of marry these two things where we could have data from multiple enterprises, use that to train sort of a single or set of machine learning techniques that could then determine when attacks are happening across all of these networks.
Very interesting. So what's the privacy challenge? I mean, it seems like this is something everyone should be doing.
Yeah, yes, that would be great if we could sort of share all of our data in the clear. The reality is that there are a number of reasons why that may not be the best option in the clear case. The main one being with commercial enterprises or commercial organizations, they don't want to share their secret sauce, to put it bluntly. And there's a lot of intellectual property concerns if we were to just share sort of network sensor data or data along those lines. But even aside from that, there can be legal concerns that creep up as well. Sharing sensitive data may reveal sort of personally identifying information, which is a non-starter. Also, you may even reveal sort of network identifying information. So you may make yourself sort of more insecure or more open to adversarial attacks by releasing some of this information. So really what's needed here is essentially to do this computation, do this training and an inference in sort of the encrypted space to preserve privacy.
Interesting. So organizations are basically trying to balance the need to catch cyber criminals with the need to keep their data private and stay competitive, which is pretty tough to reconcile. So
exactly.
What's the solution?
Yeah, so the solution we're working on is to essentially a full data science pipeline, kind of from start to finish, of in the encrypted space or in a privacy preserving way. So with multiple enterprises, they'll have sensor data or network data that they use to sort of train their individual models, but they'll encrypt it to a secure server. And then on that secure server, that will have sort of the encrypted processing or the encrypted compute performed. And so in this case, no outside observer, like even no other enterprise can sort of see the data being used from other enterprises. And after the model is trained or the inference is performed, the results are sent back to the individual organizations that can then sort of decrypt it, and only they can decrypt it.
So is it basically that model tuning, model training, and even model deployment, I guess the inference is all running on encrypted data. Is that right?
Exactly.
Very cool. So what is the future hold then, right? If this is what exists today and what DARPA is doing today, where do you see this going? What's your vision?
Yeah, there's some things I'd love to happen, and what a positive note is on the horizon. We see some of those things happening. So particularly with hardware and software advances. So, currently, encrypted computing can be fairly expensive time-wise, but there are programs now and organizations now that are working on sort of reducing that time cost, that compute cost. And so as that reduces, then we have the option of deploying sort of larger, more complex sort of machine learning models or more effective machine learning models.
So what would that ultimately mean then, right? You were talking about, basically hardware, software acceleration equals more model types, basically, right? So how does that impact the use case and the value that DARPA and other agencies or other enterprises would gain and what they'd be able to do?
Yeah, so the compute time is really important, and sort of to give some context, a sort of metric used to determine sort of the efficacy of some of these systems is when you compare it to sort of the mean time to attack, or essentially the mean time between a vulnerability surfacing or sort of being distributed widely, and then the time it takes for an attack to be seen that uses that vulnerability. So this currently has been falling steadily over the past few years, and it's at around 24 hours from sort of the vulnerability being seen to an attack being seen. And so as these compute resources become sort of more valuable, and these deeper models become more available, we should see sort of that inference time go or deployment time really go down, so that eventually we should reach the real-time protection threshold that we're aiming for.
Real-time data science on encrypted data. That's what I got from you.
That is the dream.
All right, that's hopefully happening soon. Thank you very much, Chae. Really appreciate your insights, and thanks for joining us today.
Thank you. I really enjoyed my time here.